So, good afternoon, everyone. I'm Pralipa Nayak, and I'm a machine learning developer in We Construct Private Limited, situated at Pune. So, today I'm here to present object detection in construction drawings. So, before going to that, let's uh, let's see what is object detection. So in simple words, like if I have 50 dog images and if I have 50 cat images, and I'll feed those images to a machine, and the machine will detect, like machine will find patterns in it, and like if a dog's ears looks like this and cat's ears looks like this, and cats are generally smaller than dogs, machine will find that pattern, and now we'll train the model, and when like we will give the machine a new set of images, it will tell us that if it is a cat or it is a dog. So that's basically what object detection is. So in our office there is a dedicated team which works on this thing, like OST, if anyone is aware of that. So on-screen takeoff is a platform where they count the elements that is present in 2D drawings manually. So like they have some formulas and everything, and they go one by one count it, and it takes minimum of 15 to 20 hours of the a particular team. That's where the problem statement came to us, to the ML team, to automate it, so that like they'll they'll save the time, cost, and manpower. So yeah, so the architectural plan, 2D architectural plan, it is consists of so many elements like doors, water closets, and columns, beams, electrical objects, and they count it manually. So that's one thing. Okay. So our first approach was on-screen takeoff, which I just talked about. It was a like manual effort. And then to automate that, we used machine learning techniques. So at first we started using OpenCV template matching. So it's basically suppose in a 2D architectural plan, you are finding doors. So we'll give one door template to the model, and it will match it with each and every frame of the image, and it will give us the output. But if the template image is smaller than the actual image, so it is not accurate enough. So we discard that approach, and then we move forward to custom vision, Microsoft Azure custom vision. So in custom vision, the problem was the accuracy, and we were not finding accuracy, and 2D architectural plans are very larger images, so it was not going with all those things. So yeah, and we also used TensorFlow, which is not mentioned here, and um, we faced same issues in TensorFlow as well. And our final solution was YOLO V5. So in YOLO V5, what we did is we took some doors and water closet images, small images. We labeled it using label image. Labeled it as in, we suppose we took 100 door images and 100 water closet images. We drew boxes around those doors and water closets and labeled them as doors and water closet. And we used those data set to train our model using YOLO V5. YOLO V5 is the algorithm we used, and we trained our model. And then we have used Sahi. Sahi is a Python library. So what Sahi does is, Sahi segment the images. So in 2D architectural plan, 2D architectural plans are very big images. Like we get 2D architectural plan in a PDF. So we cannot detect those images in PDF. So we have to extract the image page, the PDF pages as image, and then we have to perform object detection on it. So when we were extracting those images from the PDF pages, So it was getting pixelated, and we cannot like perform object detection on a very pixelated image. So what Sahi was doing was, okay. So what Sahi was doing was, it was segmenting the images in small images, and it was performing object detection on those small images, and afterwards it was uh, stitching the image, and we were getting the doors and water closet accuracy in it. So yeah, so that's all. Yeah, so the entire process is, we are extracting PDF pages as images. Those images are very large, and we cannot perform object detection on very large images. So we are segmenting those images in small images. Like if it is this big image, we are segmenting those to very small images, and we are performing object detection on those small images. And now that we have performed object detection on those small images, we are stitching it back. So we stitched it back. It looks something like this. It looks something like this. And now that we have everything in our image, we get the coordinates from this image, and we extract that, and we applied that in the PDF. So that's how we automated the entire process. And before, it was taking 15 to 20 hours, and now it is taking 10 to 15 minutes maximum to process 200 to 500 pages of 2D architectural drawing plan. So yeah. So do we have any question?